Hey everyone, this is Miss Englert. I'm going to show you guys this little mountain I made, and we're actually going to use this little mountain. It's actually called Sugar Cookie Mountain. We're going to use this mountain to show you what contour lines are. So first I want to start off by starting with something called scale. So when we have scale on a map, our scale is going to tell us how large features are on the scale compared to real life. So in this case, our scale on this map, it's going to be our horizontal scale is going to be 1 centimeter. So 1 centimeter equals, let's make it easy, 10 kilometers. So that means that every 1 centimeter that's on this scale, so if we look, I'm going to draw a little line here. Each of these lines, bop, 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 bop. Each one of those little segments is worth 0, and this is 5 centimeters. So what that 5 centimeters is actually 50 kilometers. Okay, so that's going to be our scale. Now I want to show you guys the mountain itself. So I'm going to lift it up. You can't really lift up mountains in real life, but let me lift this guy up. So here's our mountain. So we have a little river on front. I'm going to fix this because it cracked. So we have a little river in the front, and as you can see from the side view, our profile view, we have a peak and then we have a river, and it is a little bit steeper on the sides than it is on top. So that is going to be our mountain. I'm going to place it right there, and then I'm actually going to trace it. So I'm actually going to trace the mountain on a piece of white paper because I would like to eat this cookie dough as a form of cookie later. So I'm going to trace the base of the cookie, and again using pencil so I don't get marker on it. Okay, and there's the base of the mountain. So if I lift this guy up, I'm going to put it on my parchment paper right here. Now so that's what the base of my mountain looks like. I'm going to put it back on this lamination sheet, and then I'm going to trace it out for you. Oops, and I think got a little bit of cookie grease on my marker, and that's okay. So this baseline right here, we're going to call that sea level. So this is going to be sea level, and that is going to be 0 meters. So that line right there. So anywhere that you walk on this line, you are at sea level, 0 meters. So now you can see this is the mountain from profile view. So what I'm going to do is I have this ruler right here. Let me put it the right side up. So what I'm going to do is mark this mountain every 1 centimeter up. So the way that I'm going to do that is I'm going to take this ruler, and then I have this X-Acto knife. And remember, kids, if you have knives, they're very sharp, so you gotta be careful. So what I'm going to do is I'm actually going to hopefully not shake too much because I know I had a lot of coffee. I'm going to mark off 1 centimeter. Okay, so now hopefully you guys can see those little slices. So what I did was I marked the mountain 1 centimeter up from sea level. So that 1 centimeter is actually going to be 100 meters on our vertical scale. So again, this 1 centimeter, so that 1 centimeter you see right there, to scale, that 1 centimeter slice is going to actually be 100 meters. So now what I'm going to do is I'm going to take some string, and I am going to wrap it around my fingers like dental floss, and I am going to take some slices off of this mountain. So I'm going to start at the top. It's a very, very tiny sliver. I actually just took a little slice, and it's actually less than 1 centimeter tall. So let me put that back real fast. I actually want to measure how tall my entire mountain is. So that's my bad. Oops. That's some bad science there, Miss Englert. Okay, did not get a stick, but I do have and this is actually going to help me orient myself later. I have a reusable straw. Go green! So I have this reusable straw, and I just hit that at the top of the mountain. I'm gonna mark off a line just so I don't hit my cookie. On this map, I want to make sure that we know where north, south, east, and west are. So I'm going to make a little compass rose, and it's going to say north, south, east, and west on our little map there. And there's our mountain. That's a little slice we took off the top. I'm going to go ahead and slice the other layers. Okay, my back is killing me because that was a lot. But, so I have my layers sliced. You can actually see them over here. So those are all my layers. I sliced them off. Those are 1 centimeter each. So if I take off, this is our last layer. I'm going to take this off the bottom just to show you. So this is what the base of our mountain looks like. So it's flat, there's nothing there. If there were no dough on here whatsoever, this line would be 0 meters. Okay, so that means that at the bottom of this slice, everywhere the bottom of this slice touches is 0 meters. So anywhere that is on the bottom of this slice, again, that's sea level. So that's like the edge of a beach. If this were like an island in the Bahamas. I'm sorry, it's been a long, long semester, my dudes. Okay, so I'm going to take this guy off, and I'm going to put it on my parchment paper off to the side. And I'm going to put this next slice on. So actually, let me put them together real fast so you can see. So again, this is our bottom slice. That is the bottom of our mountain right there. And it does not want to fit because I think I put it on sideways. No, we're good. All right, so here's the bottom of our mountain. This is where it goes out to sea. So let's make sure that's there. I'm gonna put this next slice on top. This dough is a little bit crumbly, and that's okay. So this next slice would go on top. So at the bottom of that slice is 1 centimeter up. So when I mark this line, I'm actually showing the base of this layer. So let me go ahead and take this off. Now, if I leave that mountain as it is, if I were to leave it as it is, it would be 2 centimeters tall, otherwise known as 200 meters tall. That's what we had our scale be, right? So let me take this layer off here. I'm going to put it back, and then I'm going to trace it. And they are getting a little bit crumbly. So I'll line that up there. And now I'm going to go ahead and trace this. I think I might need to trace this on the paper because I don't think my pen is going to write on that anymore, unfortunately. So we're just going to have a very greasy piece of printer paper by the end of this, and that's okay. So I'm going to trace. So remember, this line that I'm tracing now is actually going to be, I believe I said my scale was 1 centimeter equals 100 meters. So that line that I just drew is actually the 100 meter line. So I'm actually going to keep stacking my cookie dough on the other side. I do plan on cooking this later and then decorating it, so we'll see how that goes. We'll see if this was a mistake. All right, so now, actually let me just show you real quick. So I have, our mountain is restacked over here, starting to fall apart. That's okay. I'll fix it later. So now we have our 2 lines so far. Remember that this bottom line is, ooh, I broke my pencil. This line is 0 meters, and this line is now 10. Oh wait, we said that was 10 meters. So our vertical scale is 1 centimeter equals 100 meters. Let me write that down before we all forget. By we, I mean me, of course, but I just like you guys to feel included, okay? All right, so I'm gonna put this next layer down. And what I'd like you guys to see, let me put this over here. It was falling apart. I'm gonna put this right here. Okay. I squished it. Learning from home is so fun. Okay, so I'm going to trace this layer. Remember now, the bottom of this layer is going to be our 2nd centimeter up. So this second centimeter up in our real scale is going to be 200 meters in our real life scale. So the mountain that, if we were actually modeling this off of a mountain, that would be our scale. Getting cookie dough everywhere. So this second line, I gotta make sure my lines are more accurate here. So this second line is going to be 200 meters. It was also easier with real mountains because real mountains don't, well, they do crumble. Hang on, let me not lie to you guys. Real mountains do crumble. It happens. So now we have our third, well, this is actually our fourth slice, but this will be our third contour line. So here is going to be our, oh my goodness, that is our third contour line I am drawing. And that is going to show 300 meters. Let me real quick show you. Here's our mountain being put back together again. Oh man, this looks way worse from here. All right, so we're gonna we have a few more layers of cookie dough to add. So let me label that before I forget. So this line here is now going to be 300 meters, technically. We got another slice here. Okay, we're looking good. Everything I own is now greasy. I don't know if this will actually cook or bake, however you, what? Like, I know you guys have probably heard this a million times, but really, we cook bacon and we bake cookies? Why does English do this to us? Okay, so that's our fourth contour line there. That is going to be, oh, it's because it's 0.5. Who uses 0.5? I am far too aggressive of a person to use 0.5. I actually really like 0.9 lead. Anyways, this line is now 400 meters. Oh, I broke it again. Okay. Here is our fifth line. Time to break some more lead. Am I out of lead? No, okay, I'm good. Did I just move my piece? Ugh. Totally just hit it. Oh, okay. Nice. Okay, that is 500 meters. Huh, this one looks like Pac-Man. Perfect, because it should, because that's an analogy I use for just a minute here. So this will be our sixth layer. Careful those contour lines don't touch. Stop moving. So this activity, when you do this activity in class, it is like a 4-person activity. So you usually have one person who holds the ruler, another person, you usually have 2 people holding the string to slice these, and then you have another person recording everything. And then you usually have myself walking around the room, also helping you. So usually you have like 4 or 5 people helping you out here. Okay, here's our last little slice. Okay. So that's our last little slice. I'm going to go ahead and trace, oh, hang on, I didn't label that last one. This last line is 600 meters. And then here is our last line here. Let me trace this. Yay! Okay, now that our last piece is off. Oh no! Oh, this mountain looks so sad. Let me show you guys. Look at this poor little mountain. Oh my goodness. Okay, so there's our river, or what's left of our river on our mountain. Here's our mountain from the side, and here is our mountain from the top. And now this is what our contour lines look like. Let me go ahead and label this last one. This last one should be 700 meters. And then the top of the mountain, I realized I actually measured it wrong earlier. The top of our mountain was, our peak was right about here, and the peak of our mountain was actually about 7.4. Oh, hang on, I don't want to write that on there, and I can't erase this, so bleh. It was actually 7.4 centimeters, which means that if we did that conversion, let me put my phone up here. So if we did that conversion, 7.4 centimeters times sine line, and we know that 1 centimeter was equal to 100 meters. So the top of our mountain is actually 740 meters tall. So this little X right here marks 740 meters to scale. Whew, okay. Let me go. I'm going to go throw these cookies in the oven actually, and I'll be back. Quick tour of our mountain. Here is our top view, our aerial view of the mountain. You can see all those little slices I made. And you can see the base of those. Each of those would be a contour line. So here is our mountain from the side. That would be from the south side. And then here is our east side view to our river. Here is our north face view. And, oh sad, here is our west side view. All right, so that is our little sugar cookie mountain. Oh, hang on, I don't orient it the right way. There we go, that's our mountain. All right, so my original cookie sheet, or rather, the tracing sheet is far too greasy to write on anymore. So I'm gonna redo this. So 1 centimeter, remember for our map scale, 1 centimeter equals 10 kilometers. So that means that however far across you are, let's go up to 5. Each of these little lines is worth 10 kilometers each. So that's 0, and this would be 50 kilometers. And then let's just 30, 40, 20, 10. I don't know why I didn't do it in order. It's just what I'm doing. So what I'm going to do is I'm going to retrace this, and I also do want to remind you that the top of the mountain, the peak, was 7.4 centimeters, and then our contour interval, so CI, was 100 meters. So this is a pretty steep mountain, so our contour interval is 100 meters. That means that every single line that's on this map is worth 100 meters. So this first line I'm drawing is sea level, otherwise known as 0 meters. So this first line is 0 meters. The second line I'm going to go ahead and trace. And remember that our contour lines cannot touch. They can get very, very close, but they cannot touch. So it just so happens that our mountain had a very steep slope. So that next one was 10, or 100, and then I'm going to go ahead and trace the rest. Okay, so now I have all of my contour lines traced again. So remember that this first one is 0, this next one is 100, next one is 200, 300, 400, 600, nope, 500, I know how to count. That's what, 500, 600, and then this line is 700. And then we mark a little X, marks the spots, and that was our peak at 740 centimeters. So this is what our contour line of our cookie mountain looks like. This is what it looks like from the top. So now that we have our mountain drawn all up, I want to add a few points on here because I want us to do a couple more activities. So what we're going to do is we're going to learn about gradient. So you may have learned about gradient before, but just to remind you that gradient is change, so we're going to use a delta for that. So change in elevation over distance. It's also in your earth science reference table for you guys. So what this means is it wants to tell us how far up do we climb for a certain distance. So how far up the mountain do we go given a certain distance. So the first one we're going to do is from A to X. So I'm going to put this up here, A to X, and I'm going to draw a line between A and X. There we go. And I also want to measure that distance, so let me actually make a table real fast here. Okay, so I did clean up a little bit because I had cookie dough everywhere. But we're going to start off by finding the elevation of A. So A is actually at sea level. So A is actually 0 meters above sea level. 0 meters. X, remember we found the peak of X earlier was 7.4 centimeters. So if we remember, our scale was by 100, so our peak is actually, X is actually 740 meters tall. Let's go look at these other lines. Luckily, all the other lines, oh, we don't even have a C. Oops. B, D, and Y are all 0 meters as well, so you're welcome for that. Keeping it nice and easy. Okay, so now we want to find the distance between A and X in centimeters. So our distance between A and X in centimeters, let's measure this out. That distance, marking it to the center of the X, that distance is 8.3 centimeters. So that distance, I don't know if my arm was in the way the whole time, I'm sorry, was 8.3 centimeters. So remember, our scale was 1 centimeter equals 10 kilometers. So what we need to do is multiply this 8.3. We need to multiply that by 10 to get our kilometers. So it is actually 83 kilometers distance between the two. So now if we want to find out our elevation change between A and X, you're going to take the higher elevation, or you're going to take the second point. So our second point is X, so it's actually going to be X meters minus A meters, all divided by the distance. So what that's going to be is 740 meters minus 0 meters, all over 83 kilometers. And then we do that math on a calculator or on your computer, in my case. And that's going to be 740 meters divided by 83 kilometers. And that's going to get you this ugly number that says 8.9157. And that's going to be meters. So these meters and the kilometers don't cancel out. So it's going to be meters per kilometer. Let's round that to the nearest tenth. So if we round that to the nearest tenth, it is 8.9 meters per kilometer. And that is the gradient between A and X.